Yes. Yes. Hmm. Yes. Our question is, show that the trajectory of an object thrown at an angle. Show that the trajectory of an object thrown at an angle with the horizontal is a parabola. Trajectory of an object. Trajectory means path of the object. So here we can say projectile. The definition of projectile: an object that is in flight after being projected. Projectile means the flying of an object when it is projected from ground to height. So here we are throwing that object making an angle theta with the horizontal. Okay, projection means we are throwing an object like this. We are throwing one ball like this. Object is throwing, making an angle theta with the x-axis or horizontal direction. Okay, so that is about trajectory of an object. What is the trajectory? Trajectory means this way or path of the object. Show that the trajectory of an object thrown at an angle with the horizontal is a parabola. So we have to show this path, this trajectory is a parabola. Okay, here object is thrown with an object is thrown with a initial velocity. That initial velocity will be u. Okay, that object is throwing in the plane means two-dimensional. Two-dimensional, we can say two-dimensional means x-axis and y-axis there. So here when object is thrown, that object velocity, initial velocity, will dividing into two components. One is a horizontal component and one is vertical component, because object is traveling in a two-dimensional place. Okay, so initial velocity, object is throwing with the u initial velocity. Initial velocity of an object. Initial velocity of an object is u. Okay, initial velocity of an object is u. This u is dividing into two components. Along x-axis u cos theta, along y-axis u sin theta. Okay, two initial velocity dividing into two components. Velocity components, velocity components of an object, object. One is a horizontal component, horizontal component of object, that is along x-axis. Ux is equal to u cos theta. Vertical component of velocity, vertical component of velocity or vertical component of an object. Uy is equal to u sin theta. Vertical component that will be along y-axis, horizontal component along x-axis. Okay, when object is thrown upward, some acceleration is acting on that object. The gravitational force is acting on object. So always gravitational force is acting downward, but according to the y-axis, gravitational force is acting downward, object is going upward. Okay, opposite direction of acceleration due to gravity. So here the velocity of horizontal component is perpendicular to the acceleration due to gravity. Okay, acceleration acting downward, that body is going in parallel, means in horizontal direction. Okay, velocity component u cos theta perpendicular to the acceleration due to gravity, and velocity component u sin theta is opposite direction to the acceleration due to gravity. So here acceleration always g, that will be along y axis, ay equal minus c. Here along x axis the velocity is constant. Velocity is constant means acceleration ax is equal to 0. Okay, ax is equal to 0. Now we have to find out the distance, horizontal distance traveled by object, vertical distance traveled by object. First we will write a horizontal distance traveled by an object. Horizontal distance, horizontal distance traveled by an object in time t. Okay, horizontal distance traveled by an object in time t. So the distance formula will be s equal ut place of a t square. Along x axis distance, yes, xi will write. Along x axis velocity uxi will write. Along x axis acceleration axi will write. Okay, sx. So distance along x axis we can take x. Okay, yes, I will take x. Ux we have u cos theta. Ux is u cos theta. Ax acceleration. Ax is equal to 0. Here we have time t. Time is same. T equal t. So all these values we have to substitute in this. Sx is equal to x. Okay, ux means u cos theta, t is as it is, plus 1 by 2, ax means 0 into t square. X is equal to u cos theta t, plus 0 into something means 0. This value will become 0. X is equal to u cos theta t. So t I will write here only, but x, u cos theta I am taking to the left side. Multiplication will be denominator. Here t equal x by u cos theta. T equal x by u cos theta. This is the equation 1. Okay. So next we can take vertical distance traveled by an object. We took horizontal distance traveled by an object is completed. Now vertical distance traveled by an object. Yes, vertical distance traveled by an object. Vertical distance traveled by an object in time t. Vertical distance traveled by an object time t. So distance formula s equal ut place of at square, is equal to ut place of at square. So vertical distance means upward. In upward distance we can write along y axis sy, uy, ay. Okay, sy distance of an object along y axis, that will be y. Uy value u sin theta we have seen in the figure. Ay equal minus g. Ay equal minus g. Okay, t equal t. So we can substitute all these values in above equation in this. Sy means y. Okay, y equal uy means u sin theta t plus 1 by 2 into ay means minus z t square, y equal u sin theta plus into minus minus g t square by 2, 1 by 2 g t square minus. This is equation 2. According to equation 1, see this equation here, t equal x by u cos theta. Okay, t equal x by u cos theta, t equal x by u cos theta. So this t value we can substitute in equation 2 at the place of t minus, this will be at the place of y equal u sin theta into x by u cos theta minus g by 2 x by u cos theta whole square. X by u cos theta is we are writing at place of t, here t instead of t, x by u cos theta instead of t, x by u cos theta square square. So this will be y equal u sin theta x by u cos theta, u cancel, minus g x square by 2 u square cos square theta. So y equal sin theta by cos theta means tan theta x, tan theta x minus gx square by 2u square cos square theta. Y equal to, instead of tan theta I am writing ax, minus instead of g 2u square cos square theta I am writing bx square. Okay, y equal to ax x square, y equal to ax minus bx square. This y equal to ax square minus bx square is the quadratic polynomial. It shows the parabola. Okay, hence proved.